So we're going to start with a bunch of definitions, and then hopefully as we go through this lesson, I'll try to give you some examples so you can actually connect the terms with what does it mean for this unit, right? So the first thing that you need to know is the universal set. Okay, it's usually referred to as set U. Okay, it refers to all possible elements that could be considered for a certain set, right? Sometimes it's also known as the sample space. Okay, I will just say I will also highlight all possible elements right there. That is the universal set. If you remember Venn diagrams, I don't know if you've ever done Venn diagrams, that's where this is ultimately going, just so you know. So if you know Venn diagrams, then I just need to define everything before I start. A capital letter, it's used to name the set or subsets, okay? And you must use braces to open and close the set, okay? So for an example, okay, if you want to have a set X and you want to, fill this in with elements of your choice, it could be the months of the year, so January, February, and so on, and then we close it. So that's the deal, that you have to have a capital letter, equal sign, and then squiggly brackets on either end if you want to write a set out like that. A set is a collection of objects that have something in common or follow a particular rule. So for example, this set, the rule would be it's the months of the year. Okay, that's just it. So sometimes it'll just tell you what it is, and then you have to make it. Element, it's the objects. So this is important, very important. Elements are the objects in a set, are called elements. Note, every element must be unique, no repeats, and it should be arranged. So I'll highlight that using a different color. Okay? Every element must be unique and no repeats. And it should be arranged. Alphabetical or numerical. Okay. Subset. So we have sets, okay, and then we have subsets. Subset is a set within a set. And what that means is that all the objects belonging to a greater set. And this is important. We use notation. I'm going to use a different color for that one. For subset, I would highlight that with a different color. We use that notation, subset. And so if you see A, that symbol B, right, what does that mean? It means that all the elements in A can be found in B. All the elements of A can be found in B. In a Venn diagram, subsets are drawn inside a set. Okay, so I'm giving you an example here. If even one element in A is not also part of B, then we write not a subset like this. Okay, so let's do an example here. You have set A has blue, green, and red. And set B has black, blue, green, red, purple. Okay, so let's see here. Is there blue? Do these things have anything in common? You do see that, right? This has blue, and there's blue right there. And then you see green, and there's green right there. I should have used the green highlighter for that, but hey. And then there's red there, and you also have red in the other one. Okay? So if I were to ask you, is A a subset of B? The answer would be yes. Why? Because every single element in A can be found in B. Think of it this way. This one is inside the other one. That's what a subset is. So we would say that A is a subset of B. It should technically be a longer, it shouldn't be a C, it should look like this. So question now, is B a subset of A? No, because not every element in B is also found in A. I will just make a note. Note, B is not a subset of A. And because sometimes the province asks you to justify why A is a subset of B. Okay, and I'll just say this. All elements in A are also found in B. That's it. That would be the justification for you making this statement. And here's your Venn diagram. You ready? A Venn diagram, by definition, needs to have a box around it. That is what we call the universal set. Okay? And in this case, we will do it this way. This is going to be set A. And set A has blue, green, oh boy, and red. I'll be able to manage there. Let me zoom into that because you're probably wondering what's going on there. Blue, green, red. And watch this. We make a bigger circle. It could be oval, it's fine. And that is going to have the letter B just outside of it like that. Okay? And so set B, this one here, has blue, green, and red. So we have that already in our diagram. So we still need to have black and purple outside of that A oval. And this is what, if you saw this, you would immediately say that A is a subset of B, immediately. Because all elements of A are also inside of B. Okay, so that's a classic. So what I've just done is I've given you a diagram to depict this. I've given you how to state it using notation. And I've also given you a way to justify that that is actually the case. So I've done 3 different things all kind of mixed up. Okay, so I hope you're all right with that. Okay. Next, if you have this n, I'm going to put an arrow to it, n of a capital letter. So if it says n of x is equal to 8, let's say, okay, that means that the number of elements, okay, so that n means that it wants to know the number of elements in the set X is actually 8. That's what that means. So let's do a very simple one. If I were to tell you set n, which should be, sorry, set X, my bad. I'm also nervous. It's my first day too. Okay. Set X, if we just went numbers 1, 2, 3, 4, 5, 6, 7, 8. So you basically just separate the elements with a comma. And remember, these could be words. In this case, I have numbers. Numbers from 1 to 8. If I were to say, hey, what's n of x? That n tells you, like, count how many elements there are. In this case, there are 8 elements. So this is how this set is, state your set, and this is how you come up with the number of elements. Okay. Next, we have the difference between infinite and finite sets. Infinite set is a set that starts or ends with a ... It indicates an infinite set. So, right, because of this and because of this, it just never ends either way. It's just not going to work out. Okay? So n of d is just infinite. Infinity. Okay? Right? That you can't come up with the number of elements for this set. It's just infinity. Let's keep going. Could I, you know what, I'm just going off on a tangent. If you had to come up with a rule that makes up this set, what would you say the rule would be? If somebody had to write out I would say consider all integers. Integers go negative infinity, positive infinity, they're whole numbers, right? And they are in increments of 10. Right? Because if you think about it, every number goes up by 10 if you go from left to right, or it goes down from right to left. So that would be kind of like the rule overseeing this one here. Okay. Next. If the number of elements is finite, countable, right, it is a finite set, right? Set is countable. So if you see something like this, okay, that tells you just, the question is not going to bother writing out all the elements because it's kind of just assumed that that's the case. Okay. And what is the rule here, by the way? What's the rule? All odd numbers? Okay. All odd numbers, but we need to narrow it down a little bit. All odd numbers from 1 to 49. This is like the rule. You're basically saying what you're observing in words. That's what we would call the rule. Okay. You came up with the rule. So all odd numbers from 1 to 49, it would be in here. Then there's something called an empty or a null set. I'm going to highlight that. So actually, can you please highlight infinite, highlight finite, empty or null set? And I'm not saying that they will ask you for every single one on the exam, but I will warn you that they may throw this as a multiple choice, or they will give you an example. What would you call these? They'll try to test you on these terms. Okay. A null set, no elements in there. No elements, therefore it's empty. The symbol for an empty set, that's important. So sometimes a symbol is required. It's a 0 with a line crossed through it, or it's just bracket, bracket with nothing in there. Okay. So for example, what would that be? The set of odd numbers divisible by 2. You can't have that, right? At least it wouldn't give you a whole number. So that would probably be an empty set. Okay. Outlier or outliers. This one I'm actually going to give you an example for. They are part of the universal set, but not part of any other sets that have been created. So let's try this. I'm going to, again, a Venn diagram meets a box. And usually there's a U outside of it. And let's say you made a set A. And this is 1, 3, 4, 5, let's say. And outside you have 6, 7, 8. Okay. So you can tell that the 6, 7, 8, and by the way, they could be anywhere outside, as long as you're within that box. But these ones are considered outliers. Sometimes there are no outliers. Sometimes there's just one outlier. So just remember, it's whatever is outside the circles, but inside the box. I don't know if you want to write that down for yourself. They're outside the circles, the sets, but they're inside the universal. Okay. So think about it. The universal is putting boundaries on the situation. So if I consider this grade 12 applied math class as my universal, then I can only make subsets that include the students that are right now in this class, not outside this class, right? So keep that in mind. So for example, considering grade 12 applied students, how many people are wearing white today? Right, and I could only count from within this set. I couldn't count anybody else. Okay, so keep that in mind. Okay. Next, equal sets. Two sets that are said to be equal if they contain exactly the same elements. They contain exactly the same elements. They're equal sets. A is a set whose numbers are the first four positive whole numbers, 4, 2, 1, 3. And since they have the exact same four elements, order doesn't matter. A and B are exactly the same. Okay. A is just written with the rules. B is like this. There's something wrong with B because it should be arranged, by the way. But that's okay. We'll just keep it like that. Let me just see here. Is there anything I need to add? Okay, let's go disjoint sets. This one is very important. I'm going to use a different color for that one. The difference between disjoint and joint sets, okay? When two or more sets, right, have no elements in common, okay? There are no common elements. They are said to be disjoint. Okay, no overlap in the Venn diagram. That's another way that you know for sure that they're disjoint. Disjoint sets are also mutually exclusive. Please have these terms on your study sheet, and just have like the little things that I've highlighted. Just have them present there. Okay. For example, the set of even numbers and the set of odd numbers are disjoint. There's no element that can be found in both. So, for example, if you had your Venn diagram and we had the even numbers, -2, 0, 2, 4, 6, and so forth, and then you had the odd numbers, okay, -1, 1, 3, and so forth, and your universal is around them, there's no overlap. No overlap. So you know just by looking at the Venn diagram, it's very easy. Okay, there's no overlap. There's disjoint. And the opposite of disjoint would be joint sets. Joint sets, two or more sets that have at least one element in common are said to be joint. In a Venn diagram, it has an overlap. Okay, and so set A, think of the student that a set which has students taking grade 12 applied and grade 12 biology. There could be students taking both. Okay, so let's make this applied, and this is biology. And that's your universal. So there would be students in here. I'm just curious, how many of you are taking grade 12 biology here? Keep your hands up. So it'd be Nico, Danica, Leah, Hannah, Zafia. That's it. That's good enough. So sorry, so these are the students that would be here. Okay? So you've got your grade 12 applied math class here, but these ones are taking both, right? So 1, 2, 3, 4, 5. 5 students are taking both, okay? So even if I had only one student in here that is taking both, that would make these sets already joint. Okay? So I'm gonna grab a highlighter here real quick and just go like this. Okay? That is a giveaway. If I ever give you a Venn diagram, you know for sure. If there's no Venn diagram, then you have to do a little bit of thinking, right? Is there is there anything that overlaps? And you know what? This is too big of a class for me to make. I could have made set A and have all the students that are right now in this class. And then set B, I could have gone to Miss Sankovic, maybe, Mr. Rollback. I think they're all teaching grade 12. I could have said, hey, give me a list of all your students, and then we could find the ones that are overlapping, right? It would be a lot more work than me just giving you a Venn diagram like this. Okay, we're almost done with terminology, but it's important for you to understand that. Okay, so complement, this one is very, very important. It will show up a lot. Every set or subset has, I think it's supposed to say has a complement. Yes. I thought I fixed it. So I'll just go like this, otherwise it's going to get messy. Every set or subset has a complement. Watch this. It is denoted, right? It is denoted, the notation is either a tick or a bar above the letter. Okay. So let's look at this. Consider U, that's a universal set. It's numbers 1 to 6. E is all the even numbers. So write this down, even. E stands for even in this case. E naught, think of E with a little tick on there is saying not it. Okay? This is literally saying not even. What do we call something that isn't even? We have a name for that, don't we? Odd numbers. But I'm still gonna emphasize the not. Okay? So which one of the universal here, which one is not even? Which numbers would apply? 1, 3, 5. Close it. Okay. I think I could do a better, I could have done a better image on this one, but it's going to come back later, so I'll just leave it like that. In general, this is very important. In general, if you take the number of elements in E, it could be any letter, guys, right? And you take everything that's not in E, you get the universal set there. I hope this makes sense. If you think about it, if we were to combine these two that I've just created, you get your universal back. Therefore, we can deduct the following. So using this formula right here, this one is the most important one to me, to be honest. This is the best way to find the complement of something. To find the number of elements that are not in E, you just take the number of elements in the universal and subtract the number of elements that are in that set to begin with. So this one I will circle. This one is very popular. So to be honest, all three of these are very much related, but I use this one the most. Let's draw a Venn diagram here. Using this information here. So I'm making a little changes here, okay? Usually next to U, we will put down the number of elements that the universal set has, which is 6. That's right here, 1 to 6. The set E has been created. So E gets a little oval like this, and we put the elements that are inside of E. And here you have to be careful. Not E is not a set, it's just everything that isn't in there, right? We wrote it as a set, but in a Venn diagram, you would just have them kind of like as outliers. So these are outliers. Which would be E like this or not E like that. So we don't make an oval for not E. We don't do that, okay? But we understand in this case, think of it this way. One more time. If you want not E, literally take away E and see what's left. That is everything that's not an E. So that's the complement, guys. They complement each other. Let's go to page 4. Sets can be expressed in 3 ways. Words describing the elements in it, actually listing the elements, and a Venn diagram. Okay? So 3 ways that sets can be presented to you. The most common is where they tell you what's in it. So watch. So we're going to fill this in as a Venn diagram. Okay? So pay close attention to this. Let's assume there's a small class of 10 students. This is the universal set. And so here it is, Anna, Biff, Chip, and notice that it's arranged alphabetically. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the universal. Okay. In this case, it's called A, but we kind of understand that that's where we can draw from. Okay. And G is the students in grade 12 applied wearing glasses. B is the students in grade 12 applied with blue eyes. How did we come up with this? Who cares? That's what the question is presenting us, right? So we know that in set G, we've got Biff, Chip, Damien, Fernando, and Jenna. In set B, we've got Chip, Jenna, and Xenia, okay? First thing before you start a graph is ask yourself, among all the sets that we're given, are there any overlaps? Do you see something in common between these two? All right, Chip is in both. Chip is there, Chip is there. Jenna is also something that is shared, right? And that's it. Are these sets joint or disjoint? They're joint, right? They have things in common. So right off the bat, you know that. So let's go ahead and make our circles. So we're gonna, I already gave you the box, you're welcome. And just make them big enough so we can write in them, okay? So this would be set G, this would be set B. And before you start filling in, we're going to do the overlap. We're going to write those names in first. Chip and Jenna. Boom. And then you need to fill in, let's B here, this part right here. What else is in B yet? There's a student named Xenia, so you write that student's name in here because it's not being shared with the other set. And over here, for G, we've got Biff, Damien, Fernando. Okay, is this good? Yeah, so far so good. So G, how many elements are in G? 1, 2, 3, 4, 5. You can also verify with this up here. So we normally put down how many elements are in there. How many are in B? 1, 2, 3. So you're like, wait a minute, the ones they share, you count them for each? Yes. So B is everything that's in B, and G, everything that is in G goes in there. So that's the number of elements. Okay. Now, don't forget about your outliers. There are things in the students in the universal set that have not been used. So we're going to cross out all the names that have already been used, okay? Biff has been used. Chip belongs to a set. Damien belongs to a set. Is Dimitri in any of the sets? No, right? So we're going to keep that one. Fernando is in one of the sets. Gurjot hasn't been mentioned. Jenna has been mentioned. Joel has not been mentioned. Xenia has been mentioned. So these are the ones that in this case will be considered our outliers. That's correct. So we're going to write them in here. So Anna, Dimitri, put commas in between, Gurjot, and Joel. Do I have 10 altogether? That would be my ultimate check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. If I counted every name, I've got 10. I'm doing good. So my universal would be outside. I don't care where you put the U. For some reason, I always put it up in the top right corner. Whatever. You can put it anywhere outside, but my universal is 10. So this is a Venn diagram in this case. We focused on what was shared. So can we put that down, joint sets? Because they're sharing, they're joint. If they had nothing in common, folks, would you have done the overlap? No. You would have had circle, circle, and they would not be touching each other. However, I asked this once on the provincial exam. What if students do this, but they leave the overlap blank? Is that all right? And apparently it is all right, as long as you don't put anything in there if there's nothing joint. Okay? All right. I'm going to answer some of these with you. And I'm gonna assign some homework already for you to try when you go home today. I know it sucks, but I want you to get going right away. Let's do true and false here for the following. If I were to ask you this, how would you read this? G is a, what does that mean? Subset of A. Is that true? True, right? Because everything in G is part of the universal, right? G is right here. Everything in G is part of the universal. So yes, this is true. I want you to explain if it's false. Okay. Is B a subset of A? Of course it is, because it's inside the universal. Is G a subset of B? No. No, false. And this is why not every element of G is in B. That's basically, I should say set G. I'm fine with you just saying, justifying it like that. Is B a subset of G? It's also false. Not all elements of B are in G. So I'm using slightly different. Okay, I'm going to ask you to just finish 4 and then 6. Write this down. Page 4 and do page 6. Finish this. Can you answer this? Okay? Thank you, guys.